Hello, welcome everyone to week 7 practice programming session for NPTEL course Getting Started with Competitive Programming. And today we are going to solve problem for topic spanning trees. So I have posted the link in the chat box. You can open that and read the problem there, or you can look at my screen. I hope my screen is visible. So uh, So I'll give you some time to read the problem statement yourself. Okay, thanks. Okay, so can any one of you explain the problem? Mm-hmm. Not possible. Is anyone speaking? Kushagra, you are not audible to me. Can others hear him? Okay, so let me. So you are given n. So you are given n lattice points, n points in a d-dimensional Euclidean space, and you are given the formula how you can calculate the distance between two points. Euclidean, that's the Euclidean distance. Initially your score is given as 1, and your target is to connect as many points as many points as possible. So the condition is that there should not be a cycle, and every time you connect a pair of points, your score is multiplied by the square of distance between them. So you have to maximize this, maximize the basically the multiplication of the distances between distances of the points that you connect with each other. And the problem is clearly related to spanning trees, and so that's the problem. You'll be given the input format is you'll be given test cases. For each test case you are given n and d, where n is the number of points, d is d-dimensional, and then for in every line you are given d space separated integers denoting the coordinates of given lattice points, and the constraints are these. So the d is always less than equal to 5. And as an example, if we have these 3 points, 3 comma 2, 0 comma 0, minus 1 comma minus 1 in a two-dimensional space, so 3 is the number of points, 2 denotes the dimension of the space, and 0 comma 0, minus 1 comma minus 1, 1 comma minus 1 are the 3 points. Then the output is 8. And the explanation is this, that the distance between the first and the second point is, you can use the Euclidean distance formula and find out and calculate that the distance between first point and the second point is square root of 2. Then first point and the third point is again square root 2, and second point and third point is 2. So one of the optimal ways is that you connect the third point and the second point, and then connect the second point with the first point. So when you chose to connect third and second point, so you got 2 square, right? Because 2 is the distance and you have to multiply your score by square of distance. So your score was initially 1, multiplied by 2 square, it became 4. After that you connected third point with the first point, and the distance between them is square root 2, so again multiplied by 2, so then your maximum score is 8. So I hope the problem is clear. If not, then let me know. I thought that the example is very simple and that's why I'm not using the board to explain it. But if you want, then I can use the board. Unfortunately, I'm not able to hear you, Kushag. Can others hear him? I don't know if it is a problem from my side. Can anybody tell? Am I audible? Okay, thanks. But I can't hear you and I don't know why. Are others able to hear? Like, can anyone speak so that I come to know that I will be able to hear? No, I can't hear you too. I can't hear you. I think it's then some problem from my side. Okay, then let me see. Okay, I can't let me see. Can anyone? No. Okay, so for a few moments I will disconnect and try to reconnect so that I can get the voice. I don't know if the meeting will end after this, so please rejoin if you guys are if you guys leave the meeting. Okay, I can just leave the call. Okay, can anyone of you speak?
Yeah. Am I
Okay.
audible now?
Oh yeah, yes, you are audible now. Yeah, okay, thank you.
Am I audible?
Yes, yes. Yes, sorry for this. Uh, okay, I'm sharing my screen again. Okay, so is the problem clear to everyone? Is the problem clear?
Yes, ma'am, it is clear.
Okay, okay, great. So, how will you solve, or what are the ideas? So, I think the problem statement is quite clear. We have to maximize uh, the distance, maximize our score, and score is actually the multiplication of the square of the distances between the points that we choose to connect. And we can connect two points as long as they do not form a cycle, right? So then,
And can I suggest my idea?
yeah, sure, go ahead.
Okay. So what I guess is, let's say we have a complete graph in starting. We can calculate the distances just by in the initial phase with the points we have, and then we can just run kind of a Kruskal's algorithm to, instead of finding the minimum edge, we'll sort it in the reverse order. That means in the higher, in a decreasing order of weights or the distances. And then we can just run a Kruskal's algorithm as the problem suggests, and that would be enough, I guess. Otherwise, what we could do is we can just start from a node and then kind of run Prim's algorithm, and at every node that we reach, we'll insert the all the distance to the points in a maxi, and then we can find the maximum spanning tree.
Yeah, yeah. So the problem is simple. You are right. So we have to find the maximum spanning tree here instead of a minimum spanning tree. And as you suggested, we sort to use the Kruskal's algorithm. To apply the Kruskal's algorithm, we just sort instead of sorting in the ascending order, we sort the edges in descending order, and then we pick the edges in that order. And yeah, that's all we have to do here. uh, yeah, so uh, yeah, it's quite clear. The problems, the approach is quite clear. We just take the maximum edge, like in Kruskal's we just take the maximum edge first and then the next one and so on. And the score is the multiplication of the distances, and that is not a problem here. uh, because maximizing the sum or maximizing the product of the numbers are both like equal. They are both can be done. There is no change required there also, even though we are, the score is actually the multiplication of the distances. Because that we can, like, one explanation that I can give for that is that if you consider that the weight of every edge is actually the log, then if you take the sum of that and you try to maximize that, then that also maximizes the product of the numbers. So is it clear to everyone else? What will be, so what are the time complexity of the what will be the time complexity of this?
I would assume it would be M and D because we have for every edge we have to like
Sorry, I can't hear you. Are you replying? I cannot hear you.
am I audible again?
Yeah, you are audible now. Yeah.
So so it would be nm into sorry n into m plus m into d. I guess that would be the complexity.
N
n
into
into n into m plus m into d.
what is M?
M is the number of edges
Okay.
and n is the number of vertices. Sorry, I'm kind of confused here. It would be, I guess, just m plus n into sorry m plus m into d because we the for the disjoints that would be just m if we use path compression and triangle union and then for md for calculating the weight of the edges and then we'll also include sorry m log m for sorting that
Yeah, for sorting it is M log M
log.
or M log N.
Yeah, and then for the calculating the weights it would be m into d that
D
would instruct the
D you can ignore. It's very small. So you can
yeah,
say
yeah,
order
yeah,
of
just
M.
hmm. Order of m. Yeah. So that would be just m log m plus m log sorry m log m plus m log n because for disjointed that would consider it as log n. That is the general worst case. And if we consider the amortized, it could be just m for m.
Yeah, so the time complexity will be order of M log N. Other factors that you are telling are smaller than M log N, right? So it will be, let's say first we sort, and if we are in Kruskal's we'll first sort, so M log N. Then after that we are going to take an edge and then add it and find to which subtree this belongs to. So we take an edge, so there are two endpoints of that edge. Then for both of the endpoints we check whether they belong to two different subtrees or the same subtree. If they belong to the same subtree, then we do not add them. Basically if they form a cycle, we do not add them, right? So that for that we are using the disjoint set union, and so we check which sets they belong in, and that we can do in order of 1. And then after that if they belong in different sets, then we add we change their sets, union of those two sets we do, which also we, if we use path compression and union by rank, then we can do both the operation in order of 1 time complexity. So overall the time complexity of the algorithm is order M log n, and which is fine for these constraints, right? So yeah, so actually I have only this problem for today. uh, do you want to look at, so have you all studied the spanning minimum spanning tree algorithms? I'm sure you have studied that in already in the this week's content.
This one done
Yeah, okay.
from my side.
Okay, okay. Right. Let me see. Yeah, actually, I don't have any other problem for today. Let me see if I can find anything. So let's try some other problem. I've randomly chosen this problem. Let's see. So the problem is, after completing the preliminary test, Full Metal now faces this final exam. So Captain gives him n cross m grid of letters. He defined distance between two rows of the grid as the largest absolute difference between letters in the same column. Full Metal is assigned to mark all the rows. The cost of marking the first row of his choice is 0. Thereafter, the cost of marking each row is equal to the distance of the row being marked from any of the previously marked rows. Help Full Metal to determine the least value of the largest cost of marking a row. I'll post the link in the chat box. Okay. Okay. Then first, can you explain the problem?
Sure. As I understand, we have a grid. Can we move to the sample? Yeah. Let's say we have this grid ABC. Then just a second, I'll open it. Okay.
Yeah.
So we have ABC, ELF, XET. Okay. And now what we have to, so for any two rows, the difference between them is the kind of maximum. Was it maximum? Just a second. I'm kind of confused here. Yeah. So the largest absolute difference between the elements would be the cost of the edge between these two rows, right? So we have, let's say, first row and second row. So the cost would be maximum of A absolute difference between A and E, B and L, C and M. So the maximum would be between B and M, L, I guess.
Yeah.
Yeah, or C and M, whatever we consider, both will be the maximum. And so the different absolute difference between them is the weight of the edge between these two rows, or the we can consider every row as a vertex of the graph that we are trying to build. And then we have to find the minimum distance of, like, choosing the edges one after the other. Uh, just a second, I'm kind of confused here again. Yeah, we have to mark each row and the minimum cost. So
Hmm.
it's basically a spanning tree. So like we have to mark every edge going from one edge to the other. Sorry, going from one vertex to the other, keeping the cost as minimal as possible. So that would be our minimum spanning tree. Like we have one edge, and just like the Prim's algorithm, we choose the minimum vertex next, and then the minimum vertex that we can get next. Basically, we have the solution just right in the question, that we have to run kind of a Prim's algorithm and find the minimum weight that we can find.
Yeah. So for here, we first choose A, B, C. So why did we choose first A, B, C and not the second row? Like first row first and not second, or what? How is the ordering? So the distance between first and second row is 10. Second and third row is x minus e, which is I think 19, right? Yeah, x minus e is 19. And what's this? So output the least value of the largest cost of marking a row. Largest cost only means the edge weight, so we have to output the least value.
So is it something like finding the maximum weightage?
Okay.
Sorry.
Mm, so the cost of marking each row is equal to the distance of the row from any one of the previously marked rows. So for example here, when we are marking first row, so cost is 0. Second row, if we mark, then already we have marked only first row, so we take the distance only from that, which is 10 here. But for the third row, we actually have marked both first and the second, so then we choose the one with the minimum distance. So from the first one, I think we have a distance around 24 x minus 24 x minus a, 24 or 23, I'm not very sure, but x minus a, and from this we have x minus e. So x minus e smaller than x minus a, so we choose this distance. So when we are marking this row, we can take any of the distances. And we have to mark all the rows and determine the least value of the largest cost of marking a row.
Is it something like instead of finding the minimum spanning tree, we just have to go through the Prim's algorithm, and instead of adding up the distances, we just have to return the map, I mean, carry forward the maximum distance that we have. Something like that. Like we got 19, so that would be the highest. But if we choose something different, that would be the case.
Yeah, so here, yeah, it's like for the third row, we have two options, and in that we have the best is 19, and for the second one we had only 10. So for then among those we are returning the maximum value here. So output format is not, I'm a little confused about the output. So we have to mark every row. I mean, basically we have to mark every row, and we do it in a efficient manner so that it's least value, and we have to report that row which has the maximum. We have to report the maximum value that is obtained in that which we have obtained so far during marking. Least value of the largest cost.
And now, the whole process, like marking every row. So we encounter several edges, and we have to return the largest edge that we'll get while doing it in a minimum distance. Something like that.
Oh, so when you're saying therefore the cost of marking every row is equal to distance per. So when we are marking one row, so for example in this, first is mark, second is mark, so we are marking the third row. So when we are marking the third row, we could have either taken the distance from the 0th row or the first row. So we took the distance from this first row, I mean ELM, which is 19. If we took it from the 0th ABC, it would have been say 23. So when we are taking the cost of marking that row, it is the minimum that we can achieve. Isn't it?
It is clear that would be the idea. I try to implement it later, I guess.
Yeah, so uh, yeah, the problem statement clearly tells that we have to apply here. We can apply Prim's algorithm here, and so when we have we one by one put mark the rows, and when we are marking a new row, then we pick the minimum weight, basically the minimum distance h from that to the already which have been marked. Is anyone trying the problem?
Then I guess implementation will take long to do, so not doing it just yet.
Okay, okay. Yeah, uh, that's all right. Yeah, so it is, we can solve this with Prince, and I will also add the link to this problem in the prob- problem sheet, and you can implement this and check as it is. And you will also, I think, be easily able to find some problem statement for maximum spanning tree to practice if you want. Spanning tree with coordinates. It's not a problem. Okay, I will find some problem where instead of minimum spanning tree, it asks to find the maximum spanning tree on some platform, and I will also add that in the problem statement. I will also add that in the problem sheet so that you can practice that as well. Yeah. So do you have any questions? Okay, so today's problems were, I think, pretty easy for you, all of you, and so we have finished the session quite early. Basically, we had finished the first problem even in before half an hour. So if you do not have any questions, then we can wrap the session now, and I'll uh, update. I will add the solutions also on GitHub, and do try them yourself first, and if you are finding it difficult, then you can check the solutions.
And one more thing. For the week 8 that we have network flows, can you suggest us some good reading material to get better idea of the concept, as it is kind of difficult concept. So
For what?
for network flows in week 8.
Oh, for max flow you're saying.
Yeah,
Okay, flows you're saying.
or yes, ma'am.
Okay, let me just check if it is there on CP algorithms or not. Hmm. Doesn't seem to be here. Okay, it's not here. I will look at some other resources. Probably I'll suggest some textbook. So you can definitely check Kleinberg and Tardos, or I'm not sure if it is there in Corman. Must be there in Corman as well, but Kleinberg and Tardos you can definitely check. So one is definitely you can check, read it from the textbook, and so for concepts I think reading a textbook will be really helpful, and for I will find more resources and I will try and put, and I'll post it on Discord. I currently it's not there on the top of my head, so
Okay, sure. Thanks.
yeah. Okay. Okay. So yeah, thanks everyone for joining. So we can end the session here. Thank you.